Okay. So let's take a look here. Gosh, you've had plenty of time to figure this out. What's 5% of 2756? 137.80? So 137.80, right? How did you type that in your calculator? You did it longhand. That's very impressive. Think so? Okay. Calculator? Anybody type it in the calculator? Yeah.
0.05 times 2756.
0.05 times 2756. So what we automatically do when we see a percent in a problem is we usually change it to a decimal, right? We understand what the percent is, but we also understand when you type it into a calculator or use it in a math problem, you've got to change it to a decimal, okay? So what we're going to talk about today is something that should be of interest to everybody. In fact, I'd say for most people, even though the problems in this section, some of them are a little bit complicated, and the idea might be hard to wrap your mind around. This concept about compounding interest is a very valuable one, and every one of you here is going to wish you had a rich uncle or a grandpa or something like that by the time we get finished. Okay? So we're first just going to describe what interest is, because as a matter of fact, everybody here is going to have to deal with interest, whether they're paying interest or interest is being paid to them at some point in their lives. So interest is the amount of money paid for the blank, okay, privilege of borrowing. Now, you may borrow money from a bank and they charge you interest. What about when you put money in a bank account, in a savings account? They give you money. So essentially they're paying you for the privilege of borrowing your money, okay? That's one way to look at it, okay? Very informal description, and it is a very small amount. A lot of savings account right now, they'll pay maybe 0.1% or maybe 0.25%, and the best loan you could possibly get might be at 3 or 4% or something like that. So they pay you a little bit for your money, but when you have to borrow from them, I mean, that's how they make money, right? They charge you a fair premium for that, okay? So it's really good when you get the interest. When someone's paying you interest, you've made an investment, you've made a loan, whatever it happens to be, you put money in a CD or something like that. That's great when you're paid interest. It's kind of a bummer when you have to turn around and pay interest on your car loan, interest on your home, interest on a student loan or something like that, okay? The simplest type of interest, not coincidentally, does anybody know what it's called? It is called simple interest. If you didn't catch that right below, it's right here, okay? With simple interest, you're paid a set percentage, so they set the interest rate for a set amount of time, and you only get paid at the end of that time. So if you agree to put your money in the bank for 6 years, and they do it at simple interest, they are going to pay you interest at the end of those 6 years, okay? Now, the key here is that you're paid interest only one time. Only once, and that's at the end. So there are several formulas that we're going to use today, and you'll hear these thrown around. Some of you may end up working in finance, at a bank, whatever it happens to be, but you need to understand these terms. So the first one is principal. Principal, we usually use a capital letter P for that, and that is the original blank borrowed or invested. Original what? Original amount. Okay? So when you can go home and talk to your parents and say, hey, what was the principal balance on our mortgage when we took that out? And they tell you that's the original amount of the loan. Okay? What was the principal amount when you put this in this investment fund? That's the money that it started with. Okay? And then we've got a rate. We use a lowercase r for that. Okay, it's short for, we could say interest rate. A lot of times we'll say percentage rate. Okay, and it's always entered in the calculator as a decimal or into a formula as a decimal. And does anybody know the formula for simple interest? Very good. Okay, it's P times R times T. I taught this in, most people learn this for the first time somewhere in middle school or something. I taught middle school for 5 years. They'd always think this was really cool because it spelled I party. I mean, they thought that was really awesome, okay? So the first example, we're going to do this. And we're going to use this dollar amount and this time period to kind of keep track of the difference between simple interest and compound interest and the different types of compound interest. So $1,000 is put in an account bearing simple interest at a rate of 8% per annum. Okay, per annum means per year. Okay, for 50 years. How much interest is due at the end of the term? So when we say at the end of the term, that's at the end of the agreement. So if you have a 5-year car loan, the term is 5 years. If you have a 30-year mortgage, the term is 30 years. Okay? So how much interest is due? Now just interest. So the interest is, what's the principal? $1,000. What's the interest rate? So we put in 0.08. And what's the time? 50. Okay? So principal, rate, and times, we just multiply those together. So if you multiply those out, what do you get? You get 4,000. Now stop and think about this for just a second. You put $1,000 in the bank. You left it there for 50 years. You come back and you say, hey, I want my money. So they give you your $1,000 back, and what else do they give you? They give you $4,000. Okay? So how much did they give you altogether? 5,000. So the amount in the account after those 50 years is $5,000. And you can go withdraw that and you're on your way. Any questions about that? What's that?
70.
I would be 82 at that point. So I'd be 92. Holy cow, that's old. Okay? Okay, so that seems like that's a lot of money, isn't it? Okay, it went up. I mean, you got 400% interest over those 50 years? That sounds pretty good, right? Okay. All right, let's see if we can do better. How could we adjust the simple interest formula so the formula gives us the amount in the account after T years instead of just the interest? So what we could do is we could start with something like this. We could say the amount is going to be the principal plus the interest. And what was the formula for the interest? PRT, right? So I get the original money back plus the interest, and the interest is PRT. What would be another way to write this so I don't have to put the P in both places? How do I make it look like there's only one P? What's that called? I heard it back here. Thank you very much. Factoring. We're going to factor this out. Okay, just like we dealt with when we were solving those logarithmic ones. If you want to make it look like there's only one, factor that out. So I get 1 plus RT. So here's the formula. The amount is going to be the principal, 1 plus R times T. Now I want you to think about this for just a second. This is 1 plus the percentage rate times the time. Okay, this 1 right here represents 100% of what you put in there. It represents the fact that you get your original principal back. And then you get a certain percentage of that based on the time. So let's solve this problem on this one right here. Let's see if we can get 5,000 directly from this formula. What's the principal? We put in 1,000. 1 plus, what's the interest rate? 0.08. And what's the time? 50. So that's going to be 1,000 and then 1 plus, what's 0.08 times 50? It's 4, isn't it? Okay, remember I said you got 400% interest? Look, you get 100% of what you put in, you get the principal back, plus 400%. So this is 1,000 times 5. So the answer here is 5,000. So this little formula right here doesn't just give you the interest, it'll tell you how much is in your account at any given time. Any questions there? Okay. Okay, we're now going to we're going to kind of develop a formula for just a second, and we're going to find a fairly interesting result, because this is what happens when we compound interest. Okay, and this is very few places would you ever find simple interest. You'd never want to lend money at simple interest, but if you could get a bank to give you a loan at simple interest, that would be a great deal, okay? Because we're going to see the power of compounding in just a second, okay? Compounding is a fancy word that means interest that is paid and added to the account at set intervals of time. So maybe every year they pay you the interest that you're due and they put it in the account. Maybe every 4 months or every 3 months or every month or maybe every day they say, I'm going to pay you a tiny little bit of interest, put it in there, okay? So the key here is that the interest is paid to the account, or is paid and added to the account. If it's added to the account, it's going to earn interest. Instead of just being paid that money at the very end, so we don't have the opportunity to earn money on it, they're going to pay us a little bit of interest every single year. Okay? And it's kind of interesting what happens to this. So let's take a look at this next example here. You'll want to grab your calculator in just a second. First couple we can do no problem. Okay, this says put $1,000 in an account bearing 8% compounded annually for 50 years. Okay, the key here is compounded annually, once per year. Compounded means they pay interest. Annually means once per year. So they're going to pay interest, put it in our account, add it to our account once every year. So let's see what this does. So if I say t equals 0, I start the stopwatch right when I put the money in the account. How much was in there at the very beginning? $1,000. We've only got $1,000. Okay? Now, after 1 year, let's use this formula that we came up with right here. Let's use that one. So the amount is going to be equal to, we put $1,000 in, and then it's 1 plus, what's the interest rate? 0.08, and what's the time? Okay, that's going to be a 1, right? Now, do I need to write that 1? Don't need to write that 1. Okay. So if I multiply these together, let's see, what's 8% of 1,000? 80. So that means I'm going to have, $1,080. Got $1,000 here, $1,080 right there. Okay, now, let's roll this over here. Now, during year 2, stop and think about this. The only thing we've got to work with is this right here. So this is going to be 1,080 times 1 plus 0.08. There's the new principal. That's how much is sitting in the account. And we're going to pay this much interest. We get all of that back, 100% plus 8%. So we do 1,080 times 1.08. What do you get? I did say grab your calculator, right? What is it? 1166.4. Is that right? Did I get that right? Okay, now what I'm going to do is I'm going to rewrite this in a little bit different way. What I did here is I paid 108%, or that's how much was in the account, 1 plus 0.08. So I'm going to do this. Instead of representing 1080 like this, I'm going to do 1 plus 0.08, and I'm going to do another 1 plus 0.08. So there's the 1080, and then I get all that money back, 100% plus 8%. Does that make sense? Is that okay? So on year 2, I take the original and I multiply it by 1.08 twice. So on year 3, I'm going to take the original and do 1 plus 0.08. That's 1 year. 1 plus 0.08. That's the second year. And another one, 1 plus 0.08. Now, this would get a little bit cumbersome and a little bit tiresome writing this out. What would be an easier way to write this? Yeah, I could write that. But what if I had to do 4 years and 5 years and so forth? Well, here I could write it squared, and here I could write it cubed. So this would be 1 plus 0.08 cubed. Does that make sense? Okay. Go ahead and type that into your calculator. 1,000 times 1 plus 0.08 and cube that. Tell me what the answer is. 1259.71. Okay. And I assume that's rounded, but there's the answer. Okay. I do just want to check and make sure that we got this one right. What I'm saying here is you could also write this one as 1,001 plus 0.08 squared. So just recall that last command. Do 1,000 times 1 plus 0.08 squared. And does it give you 1166.4? It does? Okay. All right. So is everybody convinced that that formula actually works? Okay. So a formula for compounding yearly would look like this. Take the principal, do 1 plus the interest rate, and raise that to the t. We could make an exponential out of this. That's just going to be a number, and you tell me how much time is, how many times it's going to pay interest, and we're all set to go. So after 50 years, now all they're doing is paying, like, it looks like they're paying about $80 a year, maybe a little bit more than that. Let's see what happens after 50 years. So this would be 1,000 and then 1 plus 0.08, and I'm going to raise that to the 50th. So if you type that into your calculator, what do you get? 46,901.62. Did that get it right? Okay. Take a good look at this, and I'm going to blow this up just a little bit so we can see both of these. We got $5,000 if we were paid 8% interest, simple interest paid at the very end. If we're paid the same amount of interest, 8% per year, but they take that 8%, they pay it on what's in the account, and they put it in the account, that little bit of extra every single year, look at what a huge difference it makes. We go from being paid $4,000 in interest to about $46,000 in interest. Huge difference, this whole idea of compounding. When you get paid interest and it gets added to your account, huge benefit. Guess what happens when you take out a loan and it's compound interest, which all of them are? Yeah, in the end, you do end up paying more money. It's like, holy cow, where did all that interest come from? Okay, and that's what that mortgage project is designed to show you. Okay, are there any questions there? Okay, now I want you to take a good look at this formula right here. This formula works if we're paid interest only once per year. If it's 8% a year and we're paid only once a year, you can put the 8% right there and the time there and the principal there, and that spits out the answer. But most accounts don't work that way. A mortgage, you pay interest every month. If you have a savings account, sometimes they pay monthly, sometimes they pay quarterly. You'll hear it on the radio or see it in ads or things like that. They'll say compounded quarterly. Okay? So compounded quarterly would be every 3 months or 4 times a year. Compounded monthly, every month or 12 times a year. So they pay interest more often. Okay? So, but we're going to have to adjust this just a little bit in order to come up with that formula. Okay, now this is the compound interest formula. The principal's still going to be sitting out here. So we're going to have a P out there. We're going to have an R right there, and we're going to have a T right here. So it looks very similar to the formula that we just got done looking at. The difference is, if they pay us every month, they're not going to pay us 8% a month. They're going to take that 8% and they're going to make it a little bit smaller. If they paid us every month, they divide that 8% by 12. So we'd put a 12 right here. Oops, sorry. Let me put an N right there. Okay. Whoa. Oh, that's right. We're on 150. It doesn't like to do this on 150. So we're going to put an N there. Okay. So N is the number of times they're going to pay us interest. But if they do it every month or every quarter, they're going to pay us more often. So we divide the interest rate, but guess what we get to do here? We get to multiply the time by that. So this is the compound interest formula. Principal, 1 plus R over N raised to the NT. You're going to want to memorize that. Okay? N equals number of times compounded per year. Okay, so let's go ahead and do this problem right here. It's got 4 different parts. Let's see what happens. So $1,000, 50 years, 8% interest per year, compounded quarterly. What would N be? N would be 4. So they're going to pay us interest 4 times a year. So watch what happens to this. So it's the amount in the account is going to be the principal, 1,000, and then it's going to be 1 plus 0.08 divided by 4. Now, if you're paid interest 4 times a year for 50 years, how many times would they pay you interest? $200. And guess what the exponent is? 4 times 50, so it's 200. So type that into your calculator. We want to do, come on, there we go, 1,000, 1 plus, and I realized that 0.08, whoops, 0.08 divided by 4, I realize that's 2, but or 0.02, but resist that temptation. To put this in correctly, I've got to put the exponent in parentheses, so this is going to be 4 times 50. And again, I realize that's 200, but resist the temptation to make that 200. $52,484, and what would we round this to? 90 cents. Okay, so 52,484. 52,484.90. Okay, take a look. Whoops. Take a look at that one, and that one, and that one. Here's simple interest right here. Same dollar amount, same interest rate, same time frame. Simple interest gets us $5,000. Compounded yearly, just paying once a year, gets us $47,000. And if they pay us every quarter, 4 times a year, we get it $52,500. Okay? Is this going to keep going up? Okay. What if we did it monthly? What's N then? N is 12. So it would be 1,000. 1 plus 0.08 divided by 12, raised to the 12 times 50. And again, on the calculator, if you did this the way I told you to on this one, here's what we'd want to do. I'm just going to hit second enter to recall that. And I'll go up here and I'm going to edit this. So I'm going to make that a 12, which means I need to insert. I'm going to make that a 12, which again means I need to insert. So I've got the formula typed in. Do you think this is going to be a lot bigger or just a little bit bigger? You'd think, my gosh, we're paying interest every single month, 12 times rather than 4 times. 53,878. And was it 0.13? 0.18. Did it make a big difference? I wouldn't have a problem with that. They're going to pay us $1,400 more. That's pretty good. But is it as dramatic a difference as just compounding? Simple interest, compound interest yearly. Compound interest quarterly, compound interest monthly. So it's going to be more, but the real power is any type of compounding. As long as it's yearly, you're going to get a pretty good return. If it's quarterly, we're in great shape. What if it were daily? What would N be? 365.
Are you assuming it's not a leap year? Because technically there are 365 and a quarter days per year.
Throw in a quarter. Go right ahead.
Okay,
Okay. It'll still work. Okay. Leave it to Marissa to bring up those technicalities. Yes, we are making that assumption. Okay. And what about hourly? Okay, hourly we'd have to do, let's see, 365 times 24, and that's what N would be. I mean, that's a pretty big number, but if you type those in, and you don't have to, but if you type those in, it's going to be bigger, but not that much bigger. And then we could do, gosh, not every hour, let's compound every minute. We're going to be paid a minuscule amount every minute, and that's going to be added to the account. It's going to make a difference, but a very, very tiny, tiny difference. Again, the power here is compounding. All right? Now, this idea that we could go to the extreme and say, well, gosh, what if we compounded every second or every millisecond or something like that? gets to this idea, and this is the idea of continuous compound interest. Continuous compound interest. Now, the key here, you'll notice that they both say compound interest. The key here is this one we use if it says continuous. And does anybody know what that formula is? P e to the RT. So if you don't like E, get used to this one right here, because once again, our little buddy, our little natural number E crops up in a formula. It is amazing where this comes up. If you're interested in why this is the case, I'd be happy to show you after the class. It's well beyond the scope of this course. Okay, but we can take a look at that. Now, this would be paid interest every millisecond, every nanosecond. This would be constantly paying interest. Okay? Now, there are things in real life that do change that way, but not on a consistent growth basis like this, generally speaking. Okay? There's usually something that gets in the way. We could model that. Theoretically, the stock market goes up continuously. Okay? It grows at a continuous rate. Got little fluctuations in between. Okay? There are populations that grow like that, but not money accounts. Okay? Usually doesn't work that way. But just for the sake of argument, let's see what happened if we put our $1,000 in for 50 years at 8% compounded continuously. Now, one thing you will notice is there's no N. So in my book, this formula looks a lot easier. You do this. The amount is going to be the principal, and then it's just E raised to the 0.08 times 50. So we'll grab the calculator and we'll type that in. So 1,000, and then grab exponential base E, 0.08 times 50, 54, 5, 98, 15. Again, make the comparison. Here's what we're looking at. That was the jump to compounding. That was compounding quarterly. That was compounding monthly. And this is continuous compound interest. So even if you did it daily or every hour or every minute, it's going to make a difference. Here it makes a difference of, what are we talking about? Maybe $700-800? Okay. It's going to make a difference, but again, the power here is in compounding, not necessarily how often. Don't get me wrong, I'll take the $1,400 here or so, and I take this $700 or $800 here, but the power is compounding. Okay? Any questions? Alrighty. Okay, that's all I've got today. What I'd like you to do, you don't have enough information that you could finish the assignment, but you could at least look at it. Go back and look at those formulas, try and get those memorized, make sure you understand how to use them, and more importantly, or as importantly, know how to type them into your calculator.